Hello, my name is Greg Parsons, and in this video I'll be presenting an introduction to the parallel flow intersection, or PFI. The PFI is a very high capacity signalized traffic intersection that operates using 2 or 3 phases per signal cycle. It is similar to the continuous flow intersection, or CFI, but there are very important differences. But before I talk about the PFI, I'll just ask, why is this kind of design important to consider in the first place? Well, traffic congestion seems to get worse each year, even though the transportation departments are doing their best to stem it. So meeting this challenge with traditional designs like interchanges is very high cost and takes a long time to clear environmental regulations, meaning the congestion just gets worse even as the time to bring improvements online takes longer. So just the cost of one intersection to the public measured in lost time and delay for commuters can run well into the millions of dollars. But there is a solution: the two-phase signalized intersection. This is an at-grade intersection with no bridges or retaining walls. The two-phase intersection won't solve every congestion problem, but it should be given serious consideration as an alternative to interchange construction. A two-phase signal will have fewer phases per signal cycle than a traditional signal, less startup time, shorter cycle lengths, and simultaneous vehicle movements. So all these advantages compound during operation to make the intersection very efficient. So consider this chart. PFI can reduce vehicle delay by over 80% from that of a congested conventional intersection. And it offers corresponding savings to the public by reducing lost time. PFI can pay for itself in less than a year after opening. The two-phase intersection currently comes in 2 types, the PFI and the more commonly known CFI. There are several CFIs that have been built and are currently in operation. The main difference between them is the placement of the bypass roads, with the CFI putting them directly adjacent to the approach road and the PFI adjacent to the crossroad. So for more information on the CFI, I suggest the TRB publication, Alternative Intersections, Interchanges, Informational Report. At first glance, the PFI might look confusing, but a more careful look will reveal that it's basically a standard intersection, but with channelizing islands added to guide drivers and a bypass road to remove conflicting movements from the main intersection. How does the PFI work? It's pretty simple really. Drivers turn left onto a bypass frontage road just before the main intersection. This is different than the CFI, which requires drivers to turn onto a bypass ramp far in advance of the cross street. Channelizing islands are added at the main intersection to guide drivers onto the bypass road, and a traffic divider to separate the bypass road from the cross-street traffic. The left-turning driver then turns onto the cross street at the bypass junction. By removing the left turn from the main intersection, otherwise conflicting vehicle movements can then be performed simultaneously. This is how phases are removed from the signal cycle. Constructing the PFI at an existing intersection can be a relatively quick, simple, and safer operation. In many locations, the traveling public will experience little inconvenience, since most of the work is performed on the outside of the existing roadway. So we can see from this graphic that the work zones are largely on the outsides. This will be true if no additional lanes are added to the existing roadway. The PFI can be expected to improve safety over that of conventional intersections. There are fewer conflict points, no permitted left turn movements, and pedestrians have use of refuge islands. The PFI can be constructed in a number of different arrangements. The graphic here shows T-type variants operating in 2 phases. Here is shown 2 4-leg PFI variants, 2-phase and 3-phase. The 3-phase variant can be considered as an interim improvement, with the other 2 intersection legs converted in the future to increase capacity further. And the PFI arrangement can be applied to a single leg if there is a minor side street. It can also be combined with the CFI for a 3-phase variant where property impacts would otherwise be reduced. The PFI can also be constructed in several interchange arrangements to create 2-phase operation on the arterial. The parallel flow interchange will have capacities exceeding the diverging diamond interchange, depending on the site. The physical site will determine which design is most economical. In this graphic, 2 variants of PFI diamond or PFDI is shown. For an interchange conversion, the spread variant under the freeway can be a very economical conversion, even much less expensive than the DDI, if there is space under the end spans of the bridges for the bypass lanes. A 2-quadrant diamond can also be converted to a PFDI. The ramp intersections can be arranged as PFI intersections to obtain 2-phase operation on the arterial. This is only going to be possible if the existing ramps will accommodate the bypass junctions. And finally, partial cloverleaf interchanges can be converted to a PFI parklow. Doing so will eliminate the ramp movement conflicts from the arterial. And like the PFDI, this conversion is very inexpensive, where the freeway goes over the arterial and there's enough space under the bridge end spans to fit the bypass lanes. The PFI can also be modified for different traffic and site conditions where necessary. So, in summary, the PFI can reduce intersection delay over that of conventional signals by more than 80% and will increase capacity greatly. It's intuitive for drivers since the turn movement occurs at the main intersection, providing for both direct left and right turns. It can be pretty easy to install in many circumstances. It improves safety and is pedestrian and bike friendly. And last, the PFI can be constructed in many different variants for different site and traffic conditions. The PFI is a patented design in the United States. Please contact me, Greg Parsons, if you have questions regarding royalties for using the design. In general, though, the royalties are paid as engineering fees for my involvement in the planning, design, and construction of the project. I want to thank you for watching this video introduction to the parallel flow intersection. If you have questions or want to obtain more information, contact me through the gfparsons.com website or by email Thank you.